I want you to picture a university campus or even just your old high school.
Okay.
If you close your eyes, there's usually a very distinct geography to the place, right? On one side, maybe near the parking lot, you've got the science block.
Right, the modern building.
Exactly. Lots of glass, smells faintly of formaldehyde and floor wax. Because that's where the real work happens, labs, measurements, hard facts.
The domain of certainty. Or at least, that's the vibe it gives off.
Right. And then usually way across the quad, maybe the older building with the ivy, you have the humanities. You've got the philosophy department.
Oh, yes.
And let's be honest, the stereotype there is just totally different. We imagine armchairs, elbow patches, people debating the definition of the word is while just staring out a window.
The classic two cultures divide. Oil and water. One is practical, the other is, well, abstract.
But here is the central tension we are dealing with today in this deep dive. What if that geography is a lie?
A total lie.
And not just a harmless academic sorting hat, but a mistake that is actively making us, all of us, worse at understanding the world? What if separating the lab coat from the armchair is actually the reason we are so bad at processing the news?
It's a massive question, and if you look at the source material we have today, specifically a paper by Yvonne Lampard published in the journal Science and Education, the argument is that this divorce between science and philosophy isn't just an administrative quirk. It's actually created a crisis of literacy.
It's a bold claim because, you'd think separating them allows scientists to focus on the science, right? Keep the data pure.
You would think that, yeah. But Lampert argues that by stripping philosophy out of the science classroom, we've created a generation of students and adults, frankly, who can memorize the periodic table but have no idea how to evaluate a claim they read on the internet.
They know that mitochondria is the powerhouse of the cell.
Exactly. But we are teaching facts, not the nature of facts.
And we are definitely going to get into that because the phrase Google knowing comes up in this paper, and I felt personally attacked.
It is a great term.
It really is. But before we get there, let's look at the mission for this deep dive. We are unpacking Lampert's argument that bringing philosophy back into the science classroom isn't just an academic exercise. It is essential for creating true scientific literacy in a world dominated by echo chambers and fake news.
Exactly. The goal here is to move you from being a collector of information to being a judge of information.
So let's start with the breakup. Because it wasn't always this way, right? If you go back far enough, Newton wasn't just a quote-unquote scientist.
No, the word scientist didn't even exist in Newton's time. It wasn't coined until the 1830s. Newton, Galileo, Kepler, they called themselves natural philosophers.
Natural philosophers.
Right. To them, mapping the orbit of a planet and asking what is the nature of cause and effect were part of the exact same project.
So when did the divorce actually happen?
It's really a 19th century phenomenon. Science became professionalized. It became about specialization. You stop being a generic thinker and start being a chemist or a biologist or a geologist. The fields siloed off.
And that brings us to the modern classroom. I think most of us remember our science education. It was very categorical. Here are the laws of motion, memorize them. Here is the cell, label the parts.
Right. You are learning the products of science, the finished goods, but you aren't learning the process of how we got there or the logic that justifies why we believe those products are actually true.
So you just take their word for it.
Pretty much. Lampert points out that modern education treats science as a list of established facts, completely detached from the philosophical struggle that discovered them.
It's like studying the pyramids but never talking about how they were built or why anyone wanted a giant triangle in the desert to begin with.
That's a really good analogy. And this is where the source brings in a heavy hitter to explain why this is a problem. Albert Einstein.
I was honestly surprised by this part of the research. You think of Einstein, you think of E equals mc squared, you think of the ultimate math and physics guy. But the source highlights a letter he wrote in 1944 to Robert Thornton, where he sounds more like a grumpy philosophy professor.
Einstein was deeply engaged with philosophy, people like Hume and Kant. He didn't just crunch numbers. And in that letter, he makes a fascinating claim. He says that knowing the historical and philosophical background of science is the only thing that gives a scientist independence from the prejudices of his generation.
Independence from prejudices. That is a strong phrase. What exactly does he mean there?
He means that if you only learn the current scientific facts, you are trapped in the mindset of right now. You assume the way we do things today is the only way. You become dogmatic.
I see.
But if you know the philosophy, if you understand how knowledge changes and evolves, you can see past the current trends. You can think outside the box because you know how the box was built.
He has that beautiful analogy in the letter. He says a scientist without philosophy is like someone who has seen thousands of trees but has never seen a forest.
It's the perfect image. Seeing thousands of trees means you have the data. You have the specific gravity of lead. You have the atomic number of gold. You can name every bone in the foot.
You're an expert on the bark of every single tree.
But you don't know you're in a forest.
You don't understand the ecosystem, you don't understand the connections, or why the forest is there, or how to navigate it if the path changes.
Exactly. And Einstein actually distinguishes between two types of people here. He says the philosophical thinker is a real seeker after truth, and the other one, he calls them a mere artisan or specialist.
Ouch. A mere artisan. That feels like a burn coming from Einstein.
It really is. He's saying you're a technician, you can run the experiment, you can push the buttons, but you don't understand the underlying logic of why it works or what truth even means in that context. And in a world as complex as ours, being a technician just isn't enough anymore.
This leads us directly to the concept of scientific literacy. Because I think if you stopped someone on the street, or even me, before I read this and asked, are you scientifically literate? They'd say, sure, I know the Earth goes around the sun and that antibiotics kill bacteria.
Right. We tend to conflate literacy with trivia. We think it's about having a full internal Wikipedia. But Lampert points to the PISA definition. That's the big international assessment that ranks education systems. Their definition is much tougher.
How do they define it?
They say scientific literacy isn't just recalling facts. It is the capacity to draw evidence-based conclusions and to understand the natural world and the changes made to it. It involves evaluating the quality of information, not just possessing it.
So it's active. It's not, what is the atomic weight of boron? It's more like, here's a claim about a new diet pill. Here's the study they cited. Is this study garbage?
Exactly. It's the ability to filter. It's the ability to say, wait, this conclusion doesn't actually follow from that data. And to do that, you need what Lampert calls philosophical competencies.
Okay, let's drill down into this, because philosophical competencies sounds a bit abstract, maybe a bit dry. But when you look at the list in the source, these are things we use or should be using every single day.
They are. These are mental tools. One of the big ones is the ability to distinguish description from explanation.
Walk me through that.
Okay, take gravity. If I drop a pen, it falls. Describing how it falls, the speed, the rate of acceleration, the trajectory, that's description. That is data.
Right.
But explaining why it falls, that requires a theory. Newton had one theory about forces. Einstein had a different theory about curved spacetime.
So the description is the event, the explanation is the story we tell about the event.
Yes. And if you confuse the two, you get into trouble. You start thinking that your theory is the fact. You stop questioning the explanation because you think it's just a raw description of reality.
That makes a lot of sense.
Yeah.
Another big one listed is distinguishing correlation from causation.
The classic.
Ice cream sales and shark attacks both go up in the summer, so ice cream causes shark attacks.
Right. That's the obvious one we teach kids, but it gets much harder in real life. What about coffee drinkers have lower rates of heart disease? Is it the coffee? Or do coffee drinkers just happen to have more money, less stress, and better health care?
Asking that question, is there a third variable, isn't strictly science in terms of holding a test tube. It's logic. It's epistemology.
Exactly. It's the philosophy of knowledge. Einstein had a great retort to critics who said philosophy was useless in science. He said, epistemology without contact with science becomes an empty scheme, but science without epistemology is primitive and muddled.
Primitive and muddled. I feel like that describes a lot of social media threads I've read.
It really does. If you don't check your assumptions, you're just flailing.
But I want to play devil's advocate for a second. I can hear a biology teacher listening to this and saying, look, I have to get 30 kids to pass a standardized test. I have to cover everything from DNA to ecology in 9 months. I don't have time to sit in a circle and ask, what is the meaning of life while the frogs are waiting to be dissected?
And that is a crucial distinction. Lampert is very clear here. We are not talking about campfire philosophy. We aren't talking about the meaning of life or God or ethics in some vague spiritual sense.
So we're not singing Kumbaya.
No, she is advocating for the analytic tradition of philosophy. As Hacker pointed out in 2015, this is a contribution to human understanding, not necessarily just human knowledge. It's about conceptual clarity, defining your terms so sharply that you can actually do better science.
The source gave a really cool example of this regarding cancer research. the cancer stem cell debate.
Yes, this is from a footnote in the paper referencing Laplane. It's a fascinating story. So for a long time, researchers were looking for these cancer stem cells, but they were getting completely conflicting data. The experiments weren't making sense. Different labs were getting entirely different results.
Because the biology was too hard?
No, because the language was too messy. Philosophers of biology specifically stepped in and analyzed the literature. They realized scientists were using the term stem cell to mean 4 or 5 different things.
Oh, wow.
Yeah, some meant a cell that originates the tumor, others meant a cell that sustains the tumor, others meant a cell that can regrow the tumor after chemo.
So they were talking past each other. They were using the exact same word for different concepts.
Exactly. By applying philosophical analysis, just cleaning up the definitions, they were able to show that the disagreement wasn't about the cells, it was about the words. Once they fixed the concepts, the science could actually move forward.
That is a light bulb moment for me. Philosophy isn't just thinking about stuff. It's a tool that unblocks science. It's like cleaning the lens of a microscope.
It clears the path. Another example the source uses is idealization. This one brings me back to high school physics. Remember the pendulum?
Oh, yeah. Calculating the swing.
But do you remember the conditions? The teacher says, assume a massless string. Assume no air resistance. Assume a frictionless pivot.
Right. A pendulum that doesn't exist in the real world. A ghost pendulum.
Exactly. It's a lie. Or, well, it's an idealization. Now, without philosophy, a student does the lab, gets a result that doesn't match the formula because of real-world friction, and thinks, well, I failed. I did it wrong.
My data is bad.
But a student with philosophical training understands why we idealize. They understand that the formula is a model, not a photograph of reality. They understand that science is about making maps, and maps always leave out some details to be useful.
So instead of feeling stupid, they understand the nature of the tool they're using. They know the map is not the territory.
Precisely. And that stops them from thinking science is broken just because it's not perfect.
There was one more distinction in this section that I thought was super subtle but important. The different types of why questions.
Oh, I love this one. It's the difference between explanation-seeking and reason-seeking.
Break that down first.
Okay. An explanation-seeking question asks for a physical cause. Why did the water boil? Answer, because energy was transferred to the molecules, increasing their kinetic energy until they turned to gas. Physical cause and effect.
Got it. That's the science answer.
But a reason-seeking question asks for justification. Why do we believe the water boiled? Answer, because I saw the bubbles, and the thermometer read 100 degrees, and I trust that thermometers track temperature reliably.
One is about the molecules, the other is about my evidence.
Yes. And students in the media mix these up all the time. They confuse the physical cause with the evidence for the belief. If you can't separate those, you get into trouble when you start arguing about things like climate change. Are you asking why the climate is changing, like carbon, or why we believe it is changing, like ice cores and temperature records?
That distinction is huge. And if you lack these distinctions, you fall into what the source calls the danger zones. Lampert outlines 2 main traps we fall into when we don't have this training. The first one is scientism.
Scientism is the science is God trap. It's the belief that science is the only valid way to know anything. It treats science as a dusty book of absolute facts that can never be questioned.
In this house, we believe in science yard sign, but taken to an extreme where you can't question anything.
Right. And the danger of scientism is that it's brittle. If you believe science is infallible and then a scientist changes their mind, like, oh, actually, masks do work better than we thought, you have a crisis of faith, you feel betrayed.
Because you thought it was religious dogma, not a working hypothesis.
Exactly. And that betrayal pushes you to the other extreme, which is relativism or constructivism.
This is the everything is a social construct trap.
Yes. The logic goes, well, scientists used to think the Earth was the center of the universe. They were wrong then, so they're probably wrong now. Therefore, my opinion is just as good as your data.
My truth is different from your truth.
It's a total collapse of objective reality. And Lampert argues that without philosophy, students and voters swing wildly between these two, either blind worship or total cynicism.
So how does philosophy find the middle ground? Because we don't want to be cynics, but we don't want to be sheep either.
Lampert calls the middle ground perspectivism. It's a nuanced position. It says science is a human activity. It is done by people with biases, funding issues, and egos. It is culturally situated. But that doesn't make it arbitrary. There is a great quote from Boghossian in the text. He says, "We defer to science not because it's magic, but because it is the only legitimate way to form rational beliefs, at least in the realm of the purely factual."
That's the key qualifier. In the realm of the purely factual. Science can't tell you if a poem is beautiful. It can't tell you if you should forgive your brother. But if you want to know if a vaccine works, it's the best tool we have.
Correct. And realizing that science is a tool, a fallible but incredibly powerful human tool, is what protects you from both scientism and relativism. You can trust the tool without worshiping it.
And the stakes here aren't just academic. The source mentions the Fridays for Future climate strikes. It mentions the vaccination debates. And we aren't taking sides on those policies here, but these are issues that require evaluating massive amounts of data.
This is where the rubber meets the road. If a student or a voter cannot distinguish between a peer-reviewed consensus and a conspiracy video, that is a failure of scientific literacy.
It's scary because the conspiracy video often uses sciencey language. It has graphs. It uses big words like quantum and frequency.
That's pseudoscience. And if you're a mere artisan who just memorized facts, you can be fooled because it looks like the facts you memorized. But if you're a seeker after truth who understands how evidence works, you can look at the conspiracy video and say, wait, that's a correlation, not a cause. Or that's an anecdote, not data. Or that hypothesis isn't falsifiable.
So we're convinced we need to get science and philosophy back together. They need to renew their vows. But how? Schools are rigid. Teachers are overworked. We can't just wave a wand and change the entire curriculum.
No, and Lampert is realistic about this. She critiques the integrative approach, which is where the science teacher just tries to squeeze it in during a lab.
Okay, class, open your biology books, but first let's discuss the nature of reality.
It doesn't work. The teacher is stressed about the test results. The philosophy gets cut every time. So Lampert proposes an additional and cooperative approach, a team-up.
Like a crossover episode.
Exactly. Imagine a three-phase loop. Phase 1, you go to science class, you learn the periodic law, you do the chemistry, you learn the facts.
Standard stuff.
Phase 2, you go to a separate philosophy class, and they ask, okay, you learned a law today. What is the law of nature? Is it like a traffic law? Can it be broken? What makes it different from a coincidence?
That's really interesting. A coincidence can happen 100 times, but it doesn't make it a law.
Right. Why does the law actually explain things? Then phase 3, you take those insights back into the science class. You ask better questions.
Does anyone actually do this? Or is this just a nice theory from the ivory tower?
It's rare, but it exists. The source points to the International Baccalaureate, the IB program. They have a course called Theory of Knowledge, or TOK.
I've heard of this. It has a bit of a reputation among students.
It's basically exactly what we're talking about, and the research shows it works, but it creates a funny side effect called TOK shock.
TOK shock. Sounds like a dance craze.
It's what happens when students who have spent 10 years being fed facts are suddenly asked to question the basis of those facts. They freak out. They get completely disoriented. They say, wait, are you telling me we don't know this for sure?
It's the thousands of trees problem again. They were comfortable climbing the trees. The forest is suddenly scary.
It is. It's uncomfortable to realize that truth is harder to pin down than you thought. But once they get over the shock, they become much more robust thinkers. They stop looking for easy answers and start looking for good evidence.
The challenge, of course, is that most schools aren't IB schools.
Right. Lampert acknowledges that we can't overhaul every school system overnight, but she suggests using a family resemblance approach. We don't need a perfect single definition of the nature of science. We can just teach students to look for the traits, the family resemblance of good inquiry.
Evidence, logic, falsifiability, peer review.
Exactly. Even if we can't have the full team up, we can start asking better questions.
So as we wrap this up, let's go back to Einstein. Thousands of trees, never seen a forest.
That really is the takeaway. You can win a trivia night and still be scientifically illiterate. You can know all the parts of the cell and still not understand how science works.
True literacy is knowing the machine, not just the product.
It's about possessing the tools of judgment. It's about knowing why you trust what you trust.
So here is a thought for you to chew on today. We live in a world where you can find a fact to support literally any opinion you have in about 3 seconds.
The ultimate echo chamber. Google knowing.
In that world, ask yourself, are you acting as a mere artisan of information? Just stacking up data points that make you feel good and win arguments online? Or are you a seeker after truth?
It's a tough question, and I'd add this. The next time you read a headline that says coffee causes cancer or new study proves X, just stop. Don't just read the headline. Ask yourself, do I know the difference between the observation and the conclusion here? Is this a description or an explanation? If not, do you really understand the news you just read?
That's the challenge. It takes more work, but the forest is a much more interesting place than just staring at the bark.
Thanks for diving in with us.
Keep seeking.